Hey guys, welcome to Solving Trigonometric Equations Part 1. Okay, so when we solve trigonometric equations, we're going to use algebraic methods such as combining like terms and factoring, or make sure to isolate the variable on one side of the equation. Okay, but you're going to use the ideas that you've used in algebra, algebra 2, and solving equations here. Okay, so let's look at our first example. So solve the equation 2 sine of x minus 1 equals 0. So I'm going to start by writing my original equation, and then I'm going to add 1 to both sides, and then I'm going to divide each side by 2. So I need to know, when does sine of x equal 1/2? So going back to the unit circle, where do I see y coordinates of 1/2? That happens at pi over 6 and 5 pi over 6, because the y coordinates here are 1/2. So when they're asking what is sine of x, when is sine of x equal 1/2, they're saying when are the y coordinates on the unit circle equal to 1/2? They are at x equals pi over 6 and x equals 5 pi over 6. So we want to be thinking about the radian and degree angle measures when we're finding these answers. Okay? So this is a circular function. Sine means it's periodic, it repeats over and over again. So there's not just two solutions, there's actually infinitely many solutions. So there's actually what we call a general solution to this equation. And because it's circular, because there's infinitely many solutions, the general solution for this particular problem is x equals pi over 6 plus 2 pi times n, and x equals 5 pi over 6 plus 2 pi n. N is any integer. So no matter what integer I throw in here, 1, 2, 3, 4, 5, 6, or negatives, I'm going to get one of these answers where sine of x equals 1/2. So let's look at the graph. In red, you see the graph of sine of x. Now, where in green we have the line y equals 1/2, and so where those two graphs intersect are our solutions. Okay, the first two we found from 0 to 2 pi. Okay, from 0 to 2 pi are pi over 6, which is this value right here, and 5 pi over 6, which is this value. But you can see there's more. This point right there is the multiple of that. It's pi over 6 plus 2 pi. So this point here, n would equal 1. It would give us pi over 6 plus 2 pi. That's this point right here. 5 pi over 6, if you add 2 pi, you get this point right here. That's that solution, and that would be 5 pi over 6 plus 2 pi, and again, n would be 1. So there are infinitely many solutions, and whatever n is, it can be an integer. That's how you can find all of these additional points, but there are infinitely many. So if I don't restrict your domain, you're going to have a general solution. Okay? So in the next problem, we're going to restrict our domain to 0 to 2 pi. So solve 3 tangent squared x minus 1 equals 0. So I'm going to write the original equation, and then I'm going to add 1 to both sides. I'm going to then divide each side by 3, and then I'm left with tan squared x equals 1/3, and so I'm going to take the square root of each side. When I do that, I get tangent of x equals 1 over root 3, or root 3 over 3. Now tangent values are the quotient of sine of x over cosine of x. So that particular value is not just going to be seen on the unit circle. Okay? We know that if you study the unit circle, your answers are going to be x equals 5 pi over 6 and x equals 7 pi over 4. Okay, so that's a restriction on 0 to 2 pi. There's no general solution here. Okay, so let's look at another example. We're going to again find all solutions to the equation sine of x plus root 2 equals negative sine of x on the interval from 0 to 2 pi. Now, again, I just write the original equation. I want to combine like terms. Notice I have a sign here and a sign here. So let's combine like terms by bringing over that sine x by adding it. So I did that in the second line here. And then I combine like terms to get 2 sine of x, because sine x and sine x make 2 of them, plus root 2 equals 0. Subtract root 2 from both sides, and then divide by 2. So I get where of sine of x equals negative root 2 over 2. Now, in this case, the y coordinate has to be less than 0. It's negative. So our answers are going to be in the third and fourth quadrant of the unit circle. So x is going to equal 5 pi over 4, and x is going to equal 7 pi over 4. Those are the solutions to sine of x equals negative root 2x, or root 2 over 2 on that interval. All right, this example, solve cotangent x times cosine squared x, equals 2 cotangent of x. Again, I write my original equation. This time I'm going to, again, bring the 2 cotangent over because I have a cotangent here and a cotangent here. I want them on the same side. I go ahead and do that here. And I have 2 terms equal to 0. Notice how they both have a cotangent, so in the next line I factor out a cotangent. Now, what this says is that one function times another is equal to 0. The zero product property says if I multiply 2 numbers together and get 0, one of them has to be 0. So look here. I set cotangent of x equal to 0 and cosine squared x minus 2 equal to 0. Now, cotangent is cosine x over sine of x. So we're looking for where cosine is 0 in order to make that fraction 0. Okay? So what I mean here is cotangent of x equals cosine of x over sine of x. To make any fraction 0, the numerator has to be 0. So cosine of x is 0 at pi over 2. Okay, so that's our first answer. Now, when I solve this equation, I get root 2. But root 2 is not on the unit circle. It's too large. Think of the coordinates. Where is root 2? There is no cosine value on the unit circle. That's root 2. So this one's not in our range of our unit circle. This answer is not going to count. So we're going to have the solution as x equals pi over 2 plus. Now this is a little different. There's no domain restriction here. It's going to be plus n times pi. And it's not 2 pi because, remember, the period of tangent and cotangent repeats after every pi. So here's the general solution. In our last example, find all solutions of 2 sine squared x minus sine x minus 1 equals 0 on the interval. So, when I look at this first problem, it looks pretty difficult. I look and I factor right away, and it's like, how did I know how to do that? Well, think about this. Let x equal sine of x. So then this problem becomes 2x squared minus x minus 1. So I use regular factoring methods. 2 numbers that multiply to be negative 2 and add to be negative 1 are negative 2 and positive 1. Then I divide everything by 2, each constant here by 2. And simplify, so I get x minus 1 and 2x plus 1. So that's a factoring technique that you should know from Algebra 2. So my x here is sine, so I go ahead and plug those back in. So I get 2 sine of x plus 1 times the quantity sine of x minus 1. And again, the zero product property, I set each equal to 0. So when does sine x equal negative 1/2? When does sine x minus 1 equal 0? So I'm looking for values where sine of x equals negative 1/2 and sine of x equals 1. Sine of x equals 1 at pi over 2, okay? And sine of x equals negative 1/2 on x equals 7 pi over 6 and 11 pi over 6. So those are the solutions to that. It's on the restricted domain, so it's not a general solution. Okay, keep in mind, think about that factoring here. You know, when we let x equal sine 1, that's a technique. And there's plenty of ways to factor this trinomial. I just chose to do it my way, and I went really quickly through that. So think about, 2x squared minus x minus 1 equals 0. I'm looking for 2 numbers that multiply to be negative 2 and add to be negative 1. That's minus 2 plus 1. And my factoring, I didn't account for that 2, so I divide by 2, divide by 2. These 2 simplify out, so I'm left with just x minus 1. This doesn't simplify 1/2, so I get 2x plus 1. So I can't remember the technique that's called, but that's how I did that. Okay, so that is solving trigonometric equations part 1. I'll be back for part 2 in a little bit. And if you have any questions or comments, let me know, and we'll see you next time.